Hello and welcome everyone. I'm H.Mohamed and I'm gonna be with you through the video. We're gonna talk today about linear regression with Python scikit-learn library. First of all, we have to know what is regression is. Regression is simply a prediction of a desired numeric value. This numeric value can be anything like a cost of a car. The cost of a car is usually based off a set of parameters like miles, age, and the brand of the car. Those set of parameters are known as predictors, which are very important for the calculation of predicting our numeric value. Then, linear regression. Linear regression is simply a linear model that estimates the relationship between one dependent variable and another dependent variable using a straight line. Now we're gonna go through our code. First of all, we have to import all of our library that we need, like pandas for dealing with data frames, NumPy for dealing with mathematical operation, a couple of scikit-learn library like linear regression library, train test split library, which splits our data into 70% training data and 30% testing data. Then we have matplotlib to visualization that we will see later. Now we're gonna read our data from our CSV file and make sure that is successfully imported, and this is the head, the first 5 rows of our data, and we are gonna make a copy just to make sure that if any mistake happen, we are making it with the copy, not the original data. The original data is saved with us. Now we are gonna see how our data is working, or what is our data looks like visualizing. Okay, here is our data. Oh, I'm sorry. Our CSV file or our data is about student score. Student score is based off how many hours each student take, and we are calculating those hours to calculate the percentage of each student score. Then we have to prepare our data for the prediction. Now we are gonna import our scikit-learn model that we have imported before, okay, and make our training data. Of course, we know that we have an x value and a y value. X value for hours and y value for percentage. So we have x train and x test. We have the testing data for the hours and testing data for the percentage. Okay, now we are gonna see how the splits work. Okay, we have the training data that is in blue and the testing data that is in yellow. As we can see that the number of the training data is larger than the testing data, as we said before, because the split library makes the training data up to 70% and the testing data only 30% of it. Now we're gonna train the data. Okay, we have our variable regressor that is calling the linear regression function, and the regressor is fed with xtrain and ytrain for training our data. Then we're gonna see how our data is being training for plotting like this. We are seeing here that the training data is actually making a straight line that is close to all the dots that we have that represents our training data. Now we are gonna make a prediction. First of all, we have to print the test data to make sure that is with us. Okay, this is the testing data, and we are gonna make a new variable which is ypred, which is y predicting. Okay, and this predicting variable gonna be the regressor of the predicting the x test data. Okay, now we are gonna compare our testing data that is ypred, okay, with the actual data that is ytest that we have. As we can see, the actual data is with yellow and the linear regression is a straight line that is in green. As we can see, the testing data and the predicting data is really close to each other, which means that our algorithm is working fine. Then we are gonna compare between the actual data and the predicting data. Here's gonna be then we're gonna compare between the actual data and the predicting data. We're gonna make a new data frame that is composed of the actual data, which is y-test, and the predicting data, which is y-pred. And here's what it looks like. Now we are gonna see if we have our own predicting data right. We are gonna see if we imported an hours for 9.25 and make it into our regressor, will it fit or not? It actually fit. The number of hours of 9.25 will predict a score of 93.69%, which is a very good score. Finally, we are gonna evaluate our data, and this is by scikit-learn matrix. We're gonna measure our absolute error, the the difference between the y-test and the y-pred. Okay, and here the mean absolute error equals to 4.18385. Now, here is our data. Now that we have finished explaining our code, we have our link for a GitHub account for the code and the SV files that we used. That will be linked in the video. Finally, this was H.Mohamed with you, and I have been working with Jupyter Lab. Thank you very much.